telescope.
This is instrumentation.
Roger. SBO, start report recorders and TV video tape recording.
Now on the large screen again, you see a scientist aboard the space station at the controls of a large telescope trained on the sun. This kind of solar research was begun back in the early 1970s by the Skylab astronauts. And time-lapse pictures from space like this are revealing new facts about how the sun produces energy, which may help us solve some of our own energy problems on Earth.
Halfway international date line, more or less.
This is a very interesting part of the station, where special manufacturing processes are carried out under rigorous conditions. Here you see a close-up picture of a groove being mounted in a stainless steel plate. Done in zero-G conditions, this imparts a quality to the metal we can't get under Earth gravity.
Mission control, this is Spacelab 09. Stand by for the video on B-channel.
And now through an onboard microscope and time-lapse camera, we can see the way crystals form in zero-G.
Capcom, this is Spacelab 09. The request you transmit is referring to crystal underground. 09, this is Capcom. Roger your request. Relay to B502. Capcom. 09.
These space-growing crystals are so pure that they're going to bring revolutionary advances in electronics, which will benefit every one of us. In fact, they're so... Somehow, this so incorporates the emergency system every time he comes in. I think he knows the lights on.
Excuse me, Mr. Johnson, but would you please show us what it is like for people in zero gravity? I'm sure our passengers would find that very interesting.
Of course, just a moment. Patch us into Skylab video then, please. There you see how easy it is to get from one place to another. You simply float through the air. That takes some getting used to. But zero-G has other advantages, too. Like this, for example. One man can easily handle heavy pieces of scientific equipment that he couldn't even move under normal gravity. Astronauts quickly adapt to zero-G, but over extended periods, regular exercise is absolutely vital. Here are some off-duty crew members working out in the station's gymnasium.
This is JSC Medical. MX leads now being monitored on channel 27. For this exercise period, all ECGs are heart rate 140 plus.
It's fun, but it isn't always as easy as it looks, as you can see. With a little practice, though, you can do tricks that would make a circus acrobat turn green with envy.
All personnel, switch to channel number 2 for space.
Our communication status is go. Global network status is go.
Instrumentation.
Instrumentation go.
Propulsion.
Welcome, World Flight 295 to Mars. Now ready for all number 3.
SBO.
Those small unmanned rocket ships you see leaving us will shortly be sending back television pictures as they fly into service, but we'll continue our view from orbit also. Through telescopic lenses, Mars looks even more barren, and there's definitely no sign of it being inhabited. As we know now, some things once thought to exist on Mars turned out to be only illusions, such as the famous Martian canals. But it does have some natural features that are almost as amazing. For example, this gigantic rift in Mars' surface called Mariner Valley. It's over 3,000 miles long, 10 times bigger than the Grand Canyon back home. And for a planet that's only half the size of Earth, that's pretty impressive. This superimposed outline of the United States will give you an idea of its size. Here's a closer view of the section of the rift one of our camera craft is approaching. In a few seconds, we'll have the picture it's sending back, so watch the side screens, please. There's the picture. Our camera ship is down in the rift now. Seeing this close, it looks quite Earth-like, but it's hard to get the scale of things. The wall there is almost 4 miles high, and the floor is about 50 miles across at this point. Even those branch canyons you see are 6 or 7 miles wide and go back as much as 100 miles from the main rift. This is no little canal by any means. On the upper screen, we're switching to what is literally the high point of Mars, Olympus Mons, the biggest volcano in the whole universe, as far as we know now. It's 370 miles wide at the base and over 75,000 feet high at the top. 2.5 times more than Mount Everest, the highest point on Earth. Now on the side screen is the picture from our other ship as it approaches the top of the cone. In just a moment, it'll drop down into the caldera, and you can see how big it really is. On Earth, the largest calderas are up to 10 miles across, but that's 40 miles to the opposite rim. Olympus appears to be extinct now, but just imagine what it was like when that entire area was a sea of boiling lava. Scientists estimate it was